All right, hello, geometry students. This is Mr. Zacek. We're in Unit 1, Lesson 3. We're following a little bit different order than the textbook is, so you might notice bouncing around a little bit in sections. And this is actually a little bit of a previous section in the textbook, so just if you notice that when you're working in your textbook. So we're going to talk today about measuring segments, and as we recall from previous definitions, that a segment has two endpoints, and it's all the space in between that. Okay, that's endpoints. That's my warming up with writing. Okay, so first thing, if we want to find the length of a line segment, it's the absolute value of the difference of the endpoints. So here's our segment here, AB, and so this would be B minus A. So you could think of this like on a number line. Let's say this was 1, 2, 3, 4, 5, and 6. Well, how far apart are those? 1, 2, 3, 4, 5. And that we would get from the absolute value of 6 minus 1, which is the absolute value of 5, and which equals 5. So reason why absolute value, just a reminder from algebra, is that this absolute value is always going to make this positive. And the reason for that with distance is that you can never have a negative distance. So the length of a line segment is expressed by writing the line segment without the bar. So if we want to write the length of AB, we're going to express that as AB equals 5, something like that. Just like with angles, how we used an M in our last lesson to represent measure, that's how when we're talking about the length, we write it in this way. So this will illustrate that. When numerical expressions have the same value, we say they're equal. So similarly, if two segments have the same value, then the segments are congruent. So in this first example here, where we have AB as 1 inch and we have DE as 1 inch, we would say that AB equals DE. So we write those, and notice we don't put the segment bar over this. Okay, now in this one, what's indicating that they are congruent is these tick marks right here. All right, if you have one tick mark and one tick mark, that tells you those two segments are congruent. So we're going to say segment AB, and now I'm going to put the segment symbol, no arrows, is congruent to segment DE. So just kind of a small detail, but just so you understand the difference about when we're going to use the segment bar and when we're not going to use the segment bar. One is related to measure, the other is just if we know that they're congruent. And as we said yesterday, if they're equal, they're congruent, and back and forth. Okay, so now we have the segment addition postulate, and what that says here, grab my highlighter here, is that if we have a segment, let's call it this whole segment here is AC, and we have the two parts of this segment, we've got AB and we've got BC. Did I get a different color? No, looks like the same color. BC, then if we add those two pieces together, those two pieces added together are equal to the whole. So the parts are equal to the whole. So we say AB plus BC equals AC. And that is called the segment addition postulate. And in a few minutes, we'll use that in some examples. Okay, we also have the midpoint of a segment, and midpoint is in the middle. A midpoint divides a segment into two congruent segments. So in this example, B is the midpoint of AC, so we can write that AB and AC. Okay, so if you just heard that, that was my daughter. She came into the office. Midpoint of a segment. A midpoint divides a segment into two congruent segments. So B here is the midpoint of AC. So what we can say now here with the equal side is that AB equals BC. Or we could say that AB is half of AC. Okay, that's going to be half of the total length. and we could say that BC is half of AC. And all of those things we can do interchangeably with congruent, but when we do it with congruent, we're just going to add those segment bars onto the top. So segment AB is congruent to segment BC. Segment AB is half of segment AC, and segment BC is congruent to half of segment AC. And again, with segments, you can switch the letters around. The order is not important with that. Okay, so let's turn the page here. So now we have a segment bisector, just like we talked about the other day. Bi, the prefix, means two, okay? And so we're going to cut into two parts that we have going on there. So a segment bisector divides a segment into two congruent segments. Now, the thing that sometimes can be confusing to people, you have to understand what is doing the cutting. So in this case, DBE is going to bisect, or it's going to cut AC. So if I go down here, I'll use a little highlighter to help illustrate this. AC, okay, that's this segment. AC is the segment that is being cut. Notice it doesn't say they're both being bisected. It just says that DBE bisects AC. So what that's going to do is that's going to create this segment congruent to this segment. So we could write that as AB is going to be equal to BC. Or if we want to do it with a congruent symbol, we could say that AB is congruent to segment BC. Okay, so just again, when you're seeing this written bisecting, the order of that matters and what is being bisected. So make note of what is being bisected, and that's what we'll cut through. All right, now more definitions. Perpendicular bisector. Okay, a segment bisector, we know what bisector means, cut in two, that is also perpendicular to the segment at its midpoint. All right, so let's talk about this. DBE is the perpendicular bisector of, oops, I thought I had the highlighter. Grab the highlighter back. Okay, so the perpendicular bisector of AC. So let's see, okay. So it's bisecting again AC, like that. Well, what do we know? Bisect means cut in two. So the same thing that we just did on the last one is going to be true here. AB is going to equal BC, and segment AB is going to be congruent to segment BC. Okay, now, in addition to that, all of these angles are going to be right angles, and that's because of the word perpendicular. And I'll write this definition out in just a moment. But DBA, okay, and we write a right angle with this little box symbol. That indicates that it's a right angle. All four of these are going to be right angles. And the reason here, we'll just kind of preview this because we'll use this reason, is if two lines are perpendicular, then they form right angles. Okay. And I think I've got a little kind of ditty for this song for this reason, because we use it a lot. And I might have been using that tune for vertical angles and missing the vertical angle one. So this is how I remember this little sentence. If two lines are perpendicular, then they form right angles. If two lines are perpendicular, then they form right angles. If two lines are perpendicular, then they form right angles. Okay, and we'll get a lot of practice with that as we go throughout the year. All right, so let's move on and look at a few examples here. Okay, first of all, let's find the length of AB. Okay, so let's remind ourselves that the length here of AB is going to equal the absolute value of B minus A. It's the absolute value of the difference here. Since I'm using length, I'm using the equal symbol. Well, what's B? B is 5, and a is -2. Now whenever you're subtracting a negative, if it's the second one, you should put it in its own set of parentheses. So subtracting a negative is like adding a positive. Absolute value of 5 plus 2. And so that's the absolute value of 7. So the length of AB here would be 7. All right, and don't forget your brain, right? Like you know how to count this. 1, 2, 3, 4, 5, 6, 7. Okay, we know how to count. So even though we're demonstrating this, it's going to work for examples where counting might be difficult, or maybe we have some decimal points that we're using in it, right? Just, keep that in mind, that you do have a knowledge of that and an awareness, even if that's new to you. Okay, so now we're going to get into like some simple ways that we'll use these properties that we've talked about, and how we're going to, this key couple words here, justify and explain, or we want to prove these things that we know. So it says, find Lm if L is between n and m, and NL, so I'm going to write this now on our document here. NL is 6x minus 5, and LM is 2x plus 3. And what does it say? NM, this whole segment here, equals 30. Okay? Now, this isn't really all that. So what do we know? Well, we know the parts. We know NL and we know LM. And we know if we add those two parts together, they equal the whole. So here's how we're going to write this out. Well, we have NL plus LM equals NM. And we start with this general idea. And this is the first thing I'm saying. So what is that? Well, you might recall that as the segment. Okay, addition postulate. What are we doing? We're adding two segments, parts together, and they're equal to the whole. Now what are we going to do? Well, we know what those little expressions are for NL. NL is 6x minus 5, plus LM is 2x plus 3, and we know that NM is 30. And that is what we would call substitution. So the numbers here, all I'm doing with that is giving myself a reason for why I did the action that I did. Okay, now we're going to combine. We have 6x and 2x, so that's 8x. Then we've got negative 5 plus 3 would be minus 2 equals 32. That step is simplified. We're only doing it on one side. Sometimes I like to write like hashtag CLT, combine like terms. That's always trending on Instagram. And then what are we going to do next? Well, now we're going to add 2 to both sides. So we get 8x equals 34. What did we do? We added something to both sides. That's the addition property of equality. So the addition property of equality. All right. And what are we going to do next? Well, we're going to divide, right? Going to divide by 8. And what does that come out to be? Oh, so x equals 8 doesn't go into 34 evenly. But you know what I did? I'm looking back here, and some of you have probably already caught it. You've probably been yelling at the video. He said, you brought down the 30 as 32. Like I added it twice. Let's just go back and fix that. 32, 32, and that would be 4. Okay, now, because 32 divided by 8 is 4. Not that it always has to come out as an integer, but I just knew I made a mistake in this one. And what's the reason for that? How did we go from that step to the next step? We did it with the division property of equality. Whatever you do to one side, do to the other. Okay? Now, the question was asking us for find LM. So what do we now know? Well, I know that LM is 2x plus 3. Okay, how do I know that? That was given to us. Probably should have put that in the first step. So what is LM then? Well, it's 2 times 4 plus 3. What are we doing there again? We're really substituting. Substitution property. And then we're just going to simplify that. LM is going to be 8 plus 3, which is 11. And that was a simplify step. So we've just given a justification for all of those things that we've done there. The key one here that's new for us is that segment addition postulate. Okay, so let's try another one of these. This one doesn't have the diagram, but we're going to follow kind of a very similar process. If B is between A and C, okay, B is between A and C, and A is here, let's make C over here, and B, put it in here, and AB is 20, and BC is 4x, that's this part, and then we know the whole segment length, try to represent that like this, the whole one is 7x plus 2, okay? So find the value of x, justify, and explain. Okay, again, these keywords, justify and explain, say, we've got to give a reason for all this stuff. Okay, now, what I didn't write last time, and which I really should, is at the beginning here, we just want to put in these things that were given. So AB is 20, BC is 4x, and AC is 7x plus 2. All that stuff, all we're just going to say here is we know all of that because it's given. So why do you know that? That's what our justification does. All right. Now it's going to be very similar to what we just did last time. AB plus BC equals AC. Why do we know that? That is the segment addition postulate. Okay. So, what next? Well, let's substitute in. 20 plus 4x equals 7x plus 2. And substitution postulate. Okay, sometimes I just abbreviate with a P, that's fine. All right, a little bit of a different algebra one here. People approach this different ways. I probably would subtract 2. Okay, I'm actually going to do 2 steps in one because it's the same property, the subtraction property. We would end up with 18 equals 3x. So that was, what did we do to both sides? We subtracted. We did it twice. Okay, but subtraction property of equality, both sides of the equal sign. All right, and then we're going to divide by 3. And just so you know, especially when you see this in the textbook and things, a lot of times they won't show the division, they'll just show the result. So when they divide by 3, it'll be 6 equals x. That's all you'll see. And sometimes it's like these fill in the blank ones. Well, what did we do to get from that step to the next step? It was the division property of equality. And in this one, we're just being asked to find x, so we don't need to go any further. We've got it there. Okay. Now we're going to do one with midpoint here. Let me just take a peek here. Whoops. I'll move that back. Apologize for that little formatting error. Okay, so we got a couple midpoint questions here. And then there. So let's just do, maybe what we'll do is one midpoint question, and we'll call this one a lesson here. All right, if y is the midpoint of xz, so let's put this out here, and okay, x, z at the end. All right, and then we've got y in the middle. Y is the midpoint. Okay, and then xy is 2a plus 11. I like to draw on the diagrams. And yz is 4a minus 5. Find the values of a and xz, justify all of these things. Okay, so let's just start off with what we're given. All right, y is the midpoint. Okay, of xz. We're also given that xy equals 2a plus 11 and yz equals 4a minus 5. Why do we know all that? It's given to us. We assume the things that are given are true, and that is a sound mathematical reasoning. Okay, now, what can we conclude from midpoint? Well, we can say that xy equals yz. Why do we know that? Well, we know it because this. If a point is a midpoint, if a point is a midpoint, and what does it do? Then it divides a segment. It divides a segment into two equal segments, or we could say congruent. It divides a segment into two equal segments. You could write the word out two, you could write the word equal. Either way, it doesn't matter. Okay, 3. Now what are we going to do? We're going to substitute 2a plus 11 equals 4a minus 5. Okay, and that would be our good friend substitution postulate. Now, what do we have at this point? At this point, what we need to do here is we have an algebraic problem to solve now. So we could say 4. Oh, I don't know. Different people would do this different ways. So some people might go with subtracting 11 first. Not the only way to do it, but it is a way to do it. 2a equals 4a, it would be minus 16. So what did we just do? Well, we did the subtraction property of equality. Whatever you do to one side, do to the other. And then you might repeat that process. You might subtract 4a. I'm going to show you again kind of without actually writing it down. Be negative 2a equals negative 16. What is that again here? I'm just going to write this because it's subtraction property of equality. Okay, then we're going to divide by negative 2, and we would be left with a equals 8. How did we get there? That was the division property of equality, EQ. Okay. Now, so we want to find a, and we want to also find the value of xz. Let's move this down slightly. So we already know what xz is. Well, no, actually. We know that xz is the whole segment, so we know that, let's find one of the parts here. xy plus yz equals xz. We only know the halves. So that's, what is that? Segment, addition, postulate. Okay, good. Now we need to figure out what those halves are. So we could say, okay, what's xy going to be? Well, xy is going to equal 2 times 8 plus 11. So that was substitution. Okay. when we're going to simplify that. So xy equals 2 times 8 is 16. 16 plus 11 is 27. Okay, so that would be simplify to describe what we did. All right, and then 10, I'm going to need another step. 27 plus 27 equals xz. What do we do there again? Substitution. So substitution. You can see sometimes this gets a little repetitive, but repetition is the mother of learning, as my football coach used to teach me. 54 is xz. Okay, simplify. So lots of steps, okay, things we know, but it's just getting used to this idea of we have to justify. All right, we're not going to do 5. We'll do more examples of these in our classwork. All right, go ahead and do the reflection piece next on your platform. Stop.